Hi students, in this video we will be solving question number 16 from the exercise 10.3 of the chapter straight lines, and this is a first PU syllabus. In this video we will check question number 16 and the question goes like this. If P and Q are lengths of the perpendiculars from the origin to the lines x cos theta minus y sin theta is equal to k cos 2 theta and x secant theta plus y cosecant theta is equal to k respectively, then we have to prove that p square plus 4q square is equal to k square. Let us understand the question now. There are two lines given. The perpendicular distance from the origin to these two lines are p and q respectively. Then we have to prove that p square plus 4q square is equal to k square. First, let us write down the data. I am calling this x cos theta minus y sin theta is equal to k cos 2 theta as equation 1. Henceforth, I will refer the equation, instead of writing the whole thing, I will refer it as equation 1. Okay. Now, I am calling x secant theta plus y cosecant theta is equal to k. I will refer this equation as 2. Now, let us consider rectangular coordinate system. I am considering two different lines. Let us assume that this line has the equation as x cos theta minus y sin theta is equal to k cos 2 theta, and the equation of this line be this equation 2. Okay, I could have considered the line this way also. One line like this, the other one like this. Or you could have considered a line like this and this. Anyways is fine. Fine. Okay. Now they say perpendicular distance from the origin. If you consider this distance of the line from the origin, in the question it is given that this perpendicular distance from the origin is P and perpendicular distance to this line from the origin is Q as per the data. Is this clear? So now we have to find this. See what is given. We have to consider these two. P and Q are the perpendicular distance from the origin to the given lines, right? So first we have to find the perpendicular distance given the equations of the lines. Clear? We already have discussed a formula to find the perpendicular distance from the line to a particular point or from a particular point to the line. We have already discussed that. What is that? Perpendicular distance d of a line ax plus by plus equal to 0 from a point x1 comma y1 is given by. So this is the formula. D is equal to modulus of ax1 plus by1 plus c whole divided by root of a square plus b square. So now let us understand. This is the equation of the line. In this case, 1 and 2 are the equations of the line. Ax plus by plus equal to 0 in the standard form. Now, this x1, y1 is the point from which we are calculating the distance, or we are calculating the perpendicular distance to the line. So, what is that x1, y1 in this case? It is the origin. From 0, 0, we are finding the perpendicular distance. They have given the perpendicular distance as P and Q. Fine. So, here x1, y1 will be 0, 0. Now, this a will be the coefficient of x. That is this coefficient of x. And b will be coefficient of y. Okay. And c will be the constant. When you compare, you will get to know this. And in the denominator, it is square root of coefficient of x square plus coefficient of y square. Very simple. This we have already understood. Just to help you recollect, I have explained it again. Now comparing equation 1 to the general form. So first we are considering this equation, that is equation 1, and comparing it to the general form and to know the values of a, b and c. On comparing, a is cos theta and b is minus sin theta. Then c will be minus k cos 2 theta. Okay. Now what is that point? It is 0, 0. So let us write it. It is given that P is the length of the perpendicular. This perpendicular length from the origin 0, 0 to the line 1 is, we are substituting that D is the perpendicular distance which is given as P. Then A into x1, that is cos theta into 0 plus b is minus sin theta into 0 minus k cos 2 theta. So this is the one in the numerator inside modulus. Okay. Now in the denominator, square root of cos square theta plus minus sin theta whole square. Is it clear? Cos square theta plus minus sin theta whole square, which is sin square theta only. It becomes positive. You square any term, even if it's a negative term, becomes positive. So these two terms are 0. This is just minus k cos 2 theta in the numerator inside the modulus. So let us simplify it further. That will be p is equal to modulus of minus k cos 2 theta whole divided by square root of cos square theta plus sin square theta. Now we know that for any theta, cos square theta plus sin square theta is equal to 1. So denominator is 1. Numerator will be modulus of minus k cos 2 theta. Now we know that any term, whether it is positive or negative inside the modulus, comes out to be a positive quantity. That means we will be considering the positive quantity only. And why are we doing that? Because we are finding the perpendicular distance from the origin. So distance has to be a positive quantity. So we are considering only the positive quantity. That is the reason P will be k cos 2 theta. Now I am squaring this. You know the question had p square plus 4q square. So let me square this. If I square this, p square is equal to k square into cos 2 theta whole square or cos square 2 theta. I am calling this as equation 3. Now we'll consider the second equation. Comparing the equation 2 to general form. What do we get? A is secant theta and B is cosecant theta and C is minus K. You want to check? Check this. A is secant theta, B is cosecant theta and C is minus K. Right? Now, it is given that Q is the length of the perpendicular distance from the origin. That is from x1, y1 or from 0, 0 to line 2. So, Q is the perpendicular distance. So, perpendicular distance is Q, that is equal to modulus of secant theta into 0 plus cosecant theta into 0 minus K, because x1, y1 is 0, 0. These two terms will become 0. We'll be left with only minus K in the numerator divided by coefficient of x square plus coefficient of y square, which will be square root of secant square theta plus cosecant square theta. Now, this is modulus minus k. Since we are calculating the distance, we are considering only the positive quantity. So, the numerator becomes just k. Now, see, we have to add this p square and q square, right? So, this p square is in terms of cos theta or cos 2 theta. But here it is secant theta and cosecant theta. Simplification is not possible. So, we will convert this secant and cosecant to its reciprocals. That will be q is equal to k divided by square root of 1 by cos square theta plus 1 by sin square theta. Now it is easier for us to simplify because here and here both are in sin and cos theta. Correct? We'll take LCM for this. So q is equal to k divided by square root of, when we take LCM, it is cos square theta into sin square theta. And numerator will be sin square theta plus cos square theta. So this sin square theta plus cos square theta in the numerator will become 1. This is inside the square root. Cos square theta will become cos theta. Sin square theta will become sin theta. And this goes to numerator. So q is equal to k into sin theta into cos theta in the numerator. Denominator will be square root of sin square theta plus cos square theta, which is nothing but 1. So our k is k sin theta into cos theta. Okay. Till this step it is fine. After this step, there are two possible ways of doing it. I'll show you one method and I'll explain the other method. Fine. Here, if you can recollect, the equation 3 had cos 2 theta as the angle. Here the angles are just theta. So, can we convert this also into 2 theta? Yes. By looking at the terms, it is very clear and evident that this can be converted into sine 2 theta. But what is missing? 2 is missing. So we are multiplying 2 to both sides of the equation. What do we get? 2q is equal to k into 2 sine theta into cos theta. This 2 sine theta into cos theta is nothing but sine 2 theta, right? Yes, 2q is equal to k sine 2 theta. So I'm squaring this now to get q square. 4q square is equal to k square into sine 2 theta whole square, or sine square 2 theta. I'm calling this as equation 4. Now I will add equation 3 and equation 4, which gives us p square plus 4q square is equal to k square into cos square 2 theta plus k square into sine square 2 theta, or sine 2 theta whole square. Both are same. You know this, right? Now I'm taking out k square as common. That gives us in the RHS cos square 2 theta plus sine square 2 theta. So we already know the standard form. For whatever the angle is, whether this is theta, 2 theta, 10 theta, 100 theta, whatever the theta is, sine square theta plus cos square theta will be equal to 1. So this whole term becomes 1. P square plus 4q square is equal to k square. And we have proved it now. Now I told you from this step, your approach can change. I told you, right? Yes. So we have squared it and we have added it. What other way we could have done is, we can find P and Q and consider the LHS of the given equation. In the question they have given, no, P square plus 4 square is equal to K square is what is we have to prove. You can consider the LHS part of it. That is, you can consider P square plus 4Q square. Then substitute for P and square it, plus substitute for Q square. You write 4 and substitute for Q and square it again. Then simplify. This simplification you could have done it here if you had just considered the LHS and then squared it. It's the same thing. Either you simplify here, or without simplifying you substitute and then simplify. Both are same. Is it clear? If you still have any doubt, please do mention it in the comment section.